Hello, my name is Evan Sinisak. I'm recording this short demo video for my Info 6017 AI Project 2. I started doing this and then remembered that there's supposed to be visual representation of the path, so I went and did that. So I'm gonna go through the code real quick and then I'll hit the play on Unity and just go through all the controls and what they each do. So the main bulk of the code that I ended up doing, I guess I'll go over the scene real quick first. So I took majority of what I'm doing from what we've done in class. So for the path following and formation, we needed a coordinator. So I made a coordinator that has the 12 different units. Okay, let's back up. I need to have, for the first part, we need to generate 12 different entities. I tried using a model. I spent a couple hours trying to import some assets that I've purchased off Unity store and stuff. Couldn't get anything to work. And I didn't want to, or I tried using the zombie thing that we had in class, and it also wasn't working as I wanted it to. So I ended up doing this simple unit. I know we weren't supposed to use just spheres, which is why I have the nose on it so that that points towards where it's looking and where it's going, so we can see the actual orientation as it moves and rotates. And the other thing is that I have some debug stuff going on, so they should be, I don't even know if I have everything turned on for some reason, but so like there's going to be some debug lines that we can see. So the coordinator for the path following, I started with what we had in class, just an array of vector 3s, with each one being the position on the path. I then supplemented that by having a array of objects. So I ended up making 10 nodes along the path, which is the 10 different red squares on the scene. So at the start of when I hit play, the script will find every single object that has the tag node and fill in the path objects array, and then using the object transform position, it'll fill in the path vector 3s, and then just material changing so that whatever our current node is, that one will be green and all the rest will be red. And then on the coordinator script, which is used for the formation and what I ended up using as kind of the game controller, I took the same idea. I'll have an array of vehicles, and when I hit play, it'll look for all of the vehicles that have the unit tag and add them to the list. And then I just made different arrays with 12 elements in each, and basically gave each one the positions for the different formation that I want. And then I realized that part of the formation stuff is that we wanted to be able to see when following the path, the formation has to be maintained, but they're supposed to rotate to reflect the current direction the formation is heading, which is the initial path following stuff that we did, which is to have empty objects and use their transforms as the seek position for the following units. However, because of how I'm doing the formations themselves, I had to store the information differently. So I have an array of the 12 transform positions, and then so these are hard set because they're all children of the coordinator anyways, and then depending on which formation we are using, I change the transform position of the empty object itself, and then I pass the transform position as the seek in, well, not seek, but the formation in the formation script on the objects. So the empty position offsets will rotate as the coordinator rotates and follows the path, and then the minions themselves are following the position offsets. So then I have the minions, empty object. Main purpose of this is just to generate the units themselves, since that was part of their requirements. 12, I could actually probably make this 5x5, give them actually a bit of space. And then on each unit, so this was just for testing, I'm going to delete these. I made the initial one the prefab. So on each unit I added the obstacle avoidance with a radar. It's not very strong. I actually should make that weight higher, because I noticed that they were kind of just running into each other, which was funny, but I don't know. We'll see. I'll change that back if I don't like it. But our obstacle avoidance script, which just, there's a detect objects radar that is trigger surrounding the unit. And then our formation script, I don't think I changed a little bit, which I'll get into when I actually go through the scripts. And then the flocking script, which I have the radiuses set to 100 because this is a 100 by 100 square. So this just kind of ensures that they find all the other units that are part of the flocking. But we can easily just change this during runtime to see it working, and I just made a separate controller. I could have just controlled the formation and flocking script, but I figured that was just it. Either way, it's using another get component, and for future I would likely make the flocking information more private, and the Boyd controller would be the one that actually like goes in and accesses it, rather than calling get component and getting the formation and then doing everything that way. Anyways, and then the path, like I said, these are all just 1x1 cubes at different positions with different materials, and that's really all that's in there. So as I mentioned, the coordinator is kind of the main game controller. Full disclosure, I'll discuss this first. I've been a bit stressed out. I let a few things go a bit too long, so I am basically doing this day of submission, the whole thing. I couldn't find our initial fly camera, so I just looked up something quick on Google, and this guy, Windex Glow, was very kind and made a simple fly cam that they made publicly available. So I did not make the fly camera. It's just a very simple control thing so that you can move around the scene. It's not even that particularly hard. It was just faster to do a Google search than to write it myself. So the coordinator is the main controller where a lot of the input control happens, and I basically have a bunch of different booleans and variables that keep track of the various behaviors and what is actually happening in the scene. So we already saw all the public stuff. So this is, I basically took the coordinator script that we had from class and then just added a bunch of stuff to it. So at the start, I set my position offset to the circle formation, and then I go through the list of game objects and change their positions to the position offset. And then I have to go find all the units. I found just doing vehicles equal game objects, find game objects with tag wouldn't work. So I find the game objects with tag and then I have to copy them all individually. So then in the main update, if you press keyboard 1, we set the position offset to circle formation and then run through the list and set the empty game object transforms to that position. Let's just do a quick thing. Vector 3. Update position. So wherever I do this for loop. Oops. Or no. Yeah, wherever I do this for loop, I'll just run update position. So this, update position. Change the formation to V, just run update position after. I should give that a better name. Update. What did I call them in Unity? Position object. Offset. Update position, offset objects. When you press key 3, we do the square formation. When you press key 4, we change the formation to a line. When you press key 5, we change the formation to 2 rows. When you press key 6, we go through the list of vehicles and we change and we call set flocking on all of them, which I'll go over when I go over that script. Pressing 7 calls set formation. Pressing 8 tells the coordinator to start following the path. Pressing 9 tells the coordinator to reverse the path, which on the path following script. Key 9 tells us to stop following the path. And I wasn't sure if this, I don't know, the instructions were a bit confusing to me. So key 0, stop following the path when the key is pressed. All agents must steer to their normal designated position in the formation. So the normal positions would just be, I'm assuming that just means like where they would be around the coordinator initially. So I would do the update position. I was not doing that initially. I was just letting it keep whatever angle, and then the objects would track to their respective position. It would just be angled funny depending on the direction that the coordinator was going. So I don't know, from the wording I'm assuming that this is what I'm supposed to do, but I'm not 100% certain. So following along your keyboard, after 0 is minus, which tells us that we want to start doing the flocking follow, which is basically saying tell the coordinator to start the path following and tell all of the voids to flock and follow the path. And then I figured I'll just make something easy to turn it off with equal, since that's the same key as plus. So basically I changed our update target to, instead of being the transform dot position plus the position offset, we just get the game object position offset and send that transform. And then, like I mentioned, I'm just drawing debug lines whenever I feel like it's necessary. So the red line is the line from the position offset game object to the vehicle position. And if flocking follow is turned on, then we go through and we... Did I not do... I don't think this is necessary. I don't know why I did that. Because I do it path following. Oh, no, that is... It's not necessary to do it every frame, but I decided it was easier than just running through the loop again. Which I could do it here, but that's another whatever. I'm doing it here. Since I have to set the target position anyways, and I draw a yellow line just to show where it's what each unit is targeting, and that's the update position I just wrote. So information, formation was basically just doing seek anyways, so I implemented the arrive and target radius approach behavior so that the objects actually stop once they reach their position rather than slowly circle the position. And if we're not running formation, then this function or this script will return a vector3 of 0 for the steering, and set target position just sets the target position. So the path following, essentially the same as what we were doing. Get the rigid body if it's not there, find all the nodes, and then call update path, which I'll go over at the end. So then during our calculate steering force, if follow path is true, this is just a check so that we don't move the controller or coordinator without, when we don't need to. I'm out of breath, jeez. Sorry. So this is going to be the white line that is from the coordinator to the current node that we're moving to. So as long as we actually have a path, we check the distance, and if the distance is less than the path radius, then we increase in the direction of our path, and if we're greater than the length, we set to 0, and if we're less than, then we set to the last node. And then I go through, update the materials, and then set the current node to green. And then basic seek behavior for this. And if we're not path following, then we set the rigid body velocity to 0 and return 0 on the steering. And if we call reverse path, which is only called outside from the coordinator, key 9, reverse path. I tried this a couple different ways. I ended up, I reset the materials, I change the direction of the path, and then I just increase the node, doing our regular check. So if we're currently searching for node 0, then we revert and we reverse the path, then we'll switch to search for node 10. But if we were going from 1 to 2 and we press 9, then we'll start going from 2 to 1. So this handles switching direction even in the middle of the path, which I'm sure is better and more efficient than reversing the list of stuff, which is how I was doing it at first. And then I just set the current node to the green material. An update path was just a way to update the path vector 3s to the objects vector 3s when I was physically changing the list. Obstacle avoidance and detect objects are the same as what we did in class. Flocking. Set target position. Seek. Right. So basically, in order to incorporate the following the path while flocking, I have a flocking boolean, and if it's true, so basically we're doing flocking versus formation. So if we're flocking and not for doing formation, then we run this code, which does our usual separate, align, and cohesion. And if we're following the path, if that boolean is true, then we also add the seek with no weight. It just does the full seek calculation and applies that to the body, and then we return our steer. And if we're not flocking, then we return the steer of 0. And I did formation. Generate flock is literally not changed. So Boyd controller. Basically have a connection to the formation and flocking script on the current object, as well as the weight change, because this is where I run my inputs for changing the flocking weights. So if you press Z, we increase the cohesion weight and we decrease the separation and alignment weight. I went with a fairly simple way of doing this by just I add the flocking weight in full or subtract the flocking weight in full from whichever button is being pressed, and then I do half that for the other two values. And then really the only error checking I have is that if any of the value is less than 0, then we set it to 0, and if it's greater than 0, then we set, or greater than 1, then we set it to 1. And then the set flocking and set formation calls just say, hey, formation script, set your formation boolean to false or true, and flocking script, set your flocking variable to false or true, which is called. All right. So, as I mentioned, these were my testing units, so I can delete that now since the generate Boyds or generate flock should create them. So I'm going to hit play. And if I look at my minions, unsigned the variable of vehicles has not been. So can I do that every time? Literally wasn't doing this before. Oh, because when I, right. when I applied the change, the unit was disabled. So when I'm generating the prefabs, they were all disabled. That makes sense. Now they should be enabled. There they are. Okay. So we generate our voids. There we go. We've got 12 units. We've got 12 clones. So to move this fly camera around, you hold right click to change the camera angle, and then you just use WASD to move around. The object detection is a little weird. That is a god-awful circle. Good job, guys. So if I press 2, we make the V. So the coordinator filled in all the path objects, which then filled in all the vector 3s on the nodes. And the coordinator filled in all its vehicles. And those were hard set. So let's just press 1 again, see if they can make a slightly better circle this time. Nope, those two are going to run into each other. Good steer, though. A little better. 3 is the square. So they just kind of all move into their square, where all their positions are. And if I go to the scene view, all the position object game objects have moved. So this bottom left one is wherever position offset 1 is. So I think that was 3. So if I press 4, that is the straight line, which I kept in the exact same spot. So it didn't move. But as you can see from the red debug lines, they're all just going to move to make a straight line. If I press 5, then they're going to go and move into 2 lines. I do like that detect object at 2. They're actually going around each other now, rather than running into each other and then correcting themselves. Although it was funny, because when they ran into each other, they would just start spinning in place. So that was kind of funny. So that was 1, 2, 3, 4, and 5. So I'll keep the double line for now. If I press 6, then we start doing the flocking behavior. So if I go look on my flocking information scripts, the formation boolean is now false and the formation boolean is now true. So if I press Z, the separation and alignment weight will go down and the cohesion weight will go up, and they get printed out to the console. So now the cohesion weight's 6 and the others are 2, and they're getting kind of far away, so what button? 7, right. 8. Can you guys come back? Let's just increase their speed. Get them over here. That is not actually changing them. Yeah, that did actually change their speeds. Anyways. Now that they're back in position, I'll hit 6 again. So now they're flocking. If I press X, then the values reverse. If I press C, separation goes up and the other two go down. Pressing V does the opposite. And if I press B, the alignment goes up. And if I press N, the alignment goes down. This is where my error checking should be a bit better. If you start getting real crazy with the numbers, they don't always end up adding up to 1. So I just press Z until the separation and alignment are matched, but if I press X 3 times and then I press C twice, 0.5, actually it added up this time, but then if I also press C, the alignment is 0, it's just so close to 0 it didn't fix itself. 0.7 and 0.35, so it's a little off now. And if I get it all the way to 1, we can see the separation is super strong now, so they're all gonna separate. And if I just increase cohesion until I should have some kind of checking where if I can't decrease the cohesion or the alignment, then we increase, because cohesion's at 1, so if I were to decrease cohesion, separation and alignment will go up by 0.5 and it's all good. But if I press C to increase the separation, I'm trying to decrease the alignment and the cohesion by 0.5. I should have some kind of check where if I can't do the subtraction, then I subtract the other by 1 or 0.1 instead, but I didn't end up doing that. And yeah, so separation, I was pressing V to decrease the separation, which increases the alignment and the cohesion. So now they're both at 1, which isn't what the instructions were, but it is also kind of funny to see. Like you have a bit of control over the numbers. I'm just going to reset the program to get those numbers back. And I'll hit 5, put it at in the 2 lines. So we did 6. 6 is the flocking. Now they're doing whatever. Press 7. They go back to whatever formation they were last doing. Obviously, I'm not doing any checking, so if they're in flocking and I pressed 1 for circle and then I press 7, then it's gonna go to the circle formation because I pressed circle while they were flocking. Couple minor things that I'm recognizing I should have checks for, but I'm not actually implementing checks. Anyways, so now we've got our circle. It's a real shitty circle, but if I press 8, then we start doing path following. And you can see immediately as the coordinator starts moving, all of the positions of the game objects, of the position offsets, got moved as it rotated 180 degrees and started moving towards the target. So the units are trying very hard to get into position. Now the coordinator rotated back and they're going to try very, very hard to get in position. The 2.5 was working for that before. When I was initially doing this, I just had a square that they were following in. So when I did my initial recording, I forgot to have the squares and stuff. So I went and did that real quick. Yeah, they're just not. The speed's not updating. Like, the path following is only at a 1. The units should very easily be able to catch up to it. Unless I were to do something like this and send it flying. Yeah, I don't know why. Maybe it's because the weight isn't as good. No, it's the units just aren't updating that speed for some reason. Well, one way to test that. I realize that this recording's starting to get a bit long. There's not much left to go over. I just want to see what happens if I change that. I should. That doesn't look any faster than before. I wonder if the flocking, because it should just, because this is just calculate steering, so it just returns that. Like we've done other scripts with multiple things on them. Wait, did that actually? I don't know. Very odd. Anyways, the minions following the coordinator isn't super important at the moment. For that matter, just so that we can get through the list of objects. So I think it goes, well, so it's this node to this node to the origin to top left to top, oh no, yep, to top right to here to down here, there it goes, down to bottom left, and then up a bit before going back over here to node 10. Fly, my coordinator. And the poor units are trying so hard to keep up, and then back over to the initial. So if I press 9, it reverses it. We were going to 1, now we're going to aim at 10, and then we go back to 9. And if I reverse it again, even though we were mid, we're going to reverse the direction and start going to 10, and then back to 1. If I press 0, that's the update position, so it resets the position of the empty objects and then stops the path following. There we go, that circle's better. Good job, guys. So -0. Oh god, it's so fast. So yeah, all the units they're not supposed to be creating information. It just happens that the flocking behavior creates a nice kind of diamond circle shape as they try to keep up with that. And if I press equal, it just stops the coordinator where it is, and then the units are going to go try to line up. I'm not 100% certain why the speed isn't updating during run time or at all. There's probably some override that I'm not seeing. perhaps it is the... Well, if I set that back to 1... Those are on 3. What if I just change this one? Wow, I set it to 0 and it didn't do anything, so I think there's something a little wrong with my formation. Turn position, normalize, magnitude. Distances, steers, clamp, velocity with max force. Yeah, I'm not 100% certain. Are we not on circle? Interesting. Yeah, I'm not sure why the update isn't working super well, but I think that's basically it. Thank you for watching. Have a good day. Bye.